this is sort of a brief breakdown on it, and there's probably other types of things that they provide us with also. But and the systems of storage there, for example, your capacitors would store the electricity, and your coils or your inductors would store the magnetic field. And you've got equal amount of each. Anytime you have electricity, it's a two-sided coin. You have equal amounts of each. There's no way around it, because when the electron moves forward or is disturbed, it's going to give off magnetic energy. When it pops back to where it was, it's going to give off electrical impulse. So you're going to see both of those. Yeah, I have a number of other slides, so we'll need to look at them. Okay, you're familiar with the power triangle and how that works. For example, here, the power triangle system 1 there is your L1 coil, and your L2 coil would be the power system 2. Now, the electrons are not moving from number 1 to number 2. As you noticed a while ago, the L1 coil is covered over with plastic, and that's just fine, because we don't want any of the electricity to be jumping around or sparking or moving. It's the magnetic flux lines that we're interested in. So in case of conventional energy, we've got atoms A and B there, and A would be your volts times amps. That's what's inside the wall before you turn the switch on. When you ground it, then you've got time which comes into it, which would be your volts times amps times time, which you've got watts or useful energy at that point. And that's the conventional way of doing electricity. Now, on C there, we have resonant energy, which is not actually going anywhere or doing anything, except that it's resonating, and in the process of resonating, it's creating lines of magnetic flux. And your electrical people will tell you that number C there is wattless energy or useless energy. What they're not allowing for is the fact that at resonance you have a tremendous intensity of magnetic flux lines, which will transfer beautifully over to another electrical system. And that's what's happening between your L1 and your L2 coils. Now, once you get your L2 coil going, it's going to be moving from the base of the coil towards the top of the coil. As the magnetic flux starts building on each turn there, it's transferring over to the next turn, and it's carrying with it what it had, and it's multiplying by the number of by the flux lines that are being active there. So you're getting an amplification of the magnetic flux lines. These magnetic flux lines are building in intensity as they go towards the top of the coil, and they reach their maximum at or near the top of the coil. Now, at that point, you've got high voltage with not a lot of amps, but the amp business is not going to be a problem for us, because we're not going to be using the system that we have at the top there. We're only going to be using the lines of magnetic flux. Yes?
Does this unit, do you have anything, any load on this device at all?
Well, before you can put a load on them, you have to put it into a capacitor bank and get your thing built up so that you have something to put a load against. If you try to put a load directly onto it, it's going to detune it, and you'll end up with nothing. This is going to be your L1, this is going to be your L2, and this is going to be an L3. Remember I said that the lines of magnetic flux on the distal end or the busy end of the Tesla coil are very large in number. Okay, well basically what's happening there is that this is the offtake that goes into the diode bridge that you see there. That diode bridge is built on the underside of a plastic case one half of that plastic case, it's a little box that you build electronic projects in. And coming out, what you're interested in here, this is going to be your plus DC, and this is going to be your minus DC. These are your two AC things going into the diode bridge.
Got a generator because the generators don't make electricity. They simply, by the coils and the magnets moving in relation to each other, they upset the background balance. And when that happens, well then you've got energy available, and if you have a way of collecting it, you've got energy. And a coil system, like in a normal Tesla coil, they're normally high and skinny and that sort of thing. That's the wrong way to go if you're wanting amps and stuff, because the length is volts and the diameter is amps. So if you get the right combination of this versus this, then you've got plenty of amps and plenty of volts. I've found out how to work that system now. And so I've got a lot of things which don't really on the market exist. They exist in people's minds, but they're not. There's not a demand for them. So on the electrical side, you're pretty well boxed in, and all the rules and the books and things. You're in Ohm's law and all that sort of thing. If you're in a closed system and you're boxed in, Ohm's law works, but if you get over, and that's on your electrical side, but when you move over onto the counterpart of it, the magnetic side, none of those laws apply. Right. And it's a whole different system, and most of the critical information there is missing intentionally. You have neither on matter or energy, it's neither destroyed or consumed. Everything is always there. It just simply flips over into some other temporary arrangement, and then it will end up going back to where it came from. So nothing has been used. So therefore, when the power company sends you an electric bill for electricity that you used, you did not use any. It just simply flowed through the system and went on out and went back into the system. So it's not used or worn out or degraded, or that's not the end of it at all. Up here. Okay, and what's happening is the magnetic flux in this piece of metal here is set up such that any amount of coils you put up here will duplicate whatever's being put in here. So
how do you explain the phenomenon?
okay, well, let me show you what happens when you drop it. See how fast it goes? It's heavy.
Yes.
And when you put it inside this, it's non-magnetic material, copper, and you spin it. In case anybody thinks there's some obstruction in there, if not.
Inducing its own.
This is from Bill Beatty out in California. It's one of his favorite toys. So it demonstrates the effect of gravity and nullification of gravity.
Don't spin it and drop it.
Do it?
Just drop it
Don't
straight through.
spin and drop it.
Well, the reason you spin it is because
don't
it
spin.
enforces the what's going on. If you just simply drop it,
Yeah, just
it
drop
will
it.
still.
Still,
It just takes a little longer when you spin it, and that's why I did that, to sort of emphasize how it was slowing things down.
Okay. at it for a couple of minutes here, and then we'll start talking about it. There's a number of unnecessary parts there that were actually put in there because people expect to see them. Actually, on this, you can take everything back this way and take it off of there, and it will work just fine. You can also take the spark gap off of it, and it will still work just fine. Top is the one which you normally expect to see. That's where your dampening effect happens when you're seeing these things on the oscilloscope screen, and it's showing the analog, or whatever you want to call it, showing the cycling. And it starts out with a certain amount of energy, and that gradually diminishes. Okay, the second one there is another setting on that same resonant circuit, and with a slightly different adjustment, and it shows an envelope of energy very similar to FM carrier. And in FM, you have a compression of these cycles, which takes the place of in the analog system, where you have various modulations on it. But and the third one is a particular arrangement of the grounding shunt, which means that its ability to communicate with the electron source, which would be your grounding, and the resistance there is like a dam on a large body of water, and it lets the electrons through, and they get caught behind this dam. This whole device is like a pump. All it's doing is, like the dominoes we were talking about, is tripping the electrons here, and that electron's tripping the next one, and this whole bunch of electrons in all directions are being tripped, and each time one of those would be tripped, it gives off a magnetic impulse first, and then when it comes back on that infinity loop, it gives off an electrical impulse. A room full of ping pong balls, and you get them all going in many directions. They're bouncing around. There's a certain amount of energy in that room, but if you line these ping pong balls up, and you can do it magnetically, and then all of a sudden you've got a tremendous amount of energy that was not present before. And this is what resonance is. It's what superconductivity is, and that sort of thing. Yeah, that is the shunt in the resonant radio frequency configuration that produces the dam that keeps the energy. Once it gets to oscillating inside the system, if it can come in, but it can't get out. Unless it is hooked into another system. Yeah, well, it's simply a blocking device which keeps your resonant coil system, which normally you have a capacitor and a coil, and you've got them like this. Well, in our case, we've put both the capacitor and the coil in one wire, and we've eliminated some components that are subject to fail. When we do that, capacitors are subject to fail, so you've actually made a device which is less likely to fail, because the electrons are not going through the wire, and there's no dissipation factor, and they're spinning on the outside of the wire, so you can have this corona effect. See, I told you they were somewhere else. Okay, just put them on the table here, and whenever I get to them, I've got some magnets here which I want to demonstrate something for you. See, how much voltage would you think it would take to penetrate a quarter of an inch of PVC? It'd take a lot of it, wouldn't it? Maybe even a million volts. Okay, what I'm going to do here, I'm going to show you how the magnetic effect, it varies from Okay, your induction is from magnetic effect. So you could take these wires, they can have a covering on them, they can be encapsulated, you can put them in solid concrete or plastic or anything else inside, completely insulated from everything. And these wires, when the induction effect starts taking place, which is magnetic, it doesn't see any of it. So that's why your induction works so well.